Welcome to another video. Today's learning objective is an introduction to probability. So as you can see, I've kind of actually started with a new numbering system. This is a P lesson 1. So this is the part of the series which is devoted to probability. So I thought since it's a different thing and to prevent the numbers from getting a bit too large, I thought why not P lesson 1 now. So what we're going to be talking about, this is the word what probability is, and you've probably come across this loads of times, but one of the classic examples of everyone introduce probability, what we ask is say for example, if we have a coin and we think about the probability of the coin landing on a heads or tail, and so heads this side and I guess tails on the other. I can't really show that, but that's kind of the classic question that comes up. And then if you're wondering what the probability of heads is, for example, you'd say something like P brackets heads, and that equals something, some number, maybe, I don't know, we can say instead of question mark, let's put an X, it equals something. And from this you can kind of tell what probability is. It's asking us to somehow capture some information around something that's kind of random. Nobody knows when you flip the coin if it's going to go heads or tail. That's completely up to a random chance. But what we're trying to do is kind of encapsulate this idea about kind of what's the likelihood that it's going to be something, and what's the likelihood it might be something else. We're thinking about kind of the chance it could be something. And the way you can say calculate the probability of a heads, what you do is you think about kind of how many outcomes are there. So in this case, either there can be a heads or there can be a tails. And because if we know that, for example, this is a fair coin, it's equally likely for there to be a heads or a tails, right? Because that's what kind of fair coin does. So we know we think about the number of outcomes likely, so number of, let's say, of outcomes, and the probability we're concerned with is probability of heads. We'll think about what's the number of outcomes which satisfy our condition, or what we're concerned with. Satisfy our condition. Ooh, I spelled that wrong. Our condition. So the number of outcomes would satisfy a condition. Well, there's only one outcome that satisfies a condition, right? There's only one time it comes heads. If it's tails, that's not satisfying our condition. So the top number is 1, and kind of the outcome, the number of outcomes there are, it can be heads or tails, and it's either of those. So there's only 2 outcomes, right? So our probability that we're concerned with is then a half, or kind of as a percentage, we might say it's 50%, or as a decimal, 0.5. And so this is kind of how we might be thinking about probability of heads coming up. But what would the probability of it being tails be, for example? Well, again, let's think about this. The number of outcomes which satisfy a condition. There's only one outcome that actually satisfies a condition. There's only one tail, right? And again, there's 2 outcomes. So again, the probability is a half. Let's think of another example to kind of help solidify this idea. The other classic example is some dice. So let me just have a badly drawn dice. Die or dice? Well, it's a single, right? So dice, yeah. Badly drawn dice. There's one here. I don't know, does 4 go on there? I think I don't know. No, it's actually 6, isn't it? It'd be 6 here, and I don't know, 4 here, for example, right? So kind of this is a badly drawn dice, and if we think about with the dice, there's kind of 6 outcomes that can happen, right? It can be a 1, 2, 3, or 4, or 5, or 6, right? So we can say so the number that comes up when you roll the dice. So let's just call that outcome maybe, or no, not outcome. Say face of the dice. Face of dice. So it could either be a 1, or it could be a 2, it could be a 3, it could be a 4, it could be a 5, and it could be 6. And this is a fair dice. Each of these is equally likely. So if I ask you, for example, the P that the dice shows, for example, 1. Well, okay, there's 6 total outcomes, and only one of these satisfies our condition. So it's 1 over 6, for example. If we're thinking about, say, for example, probability, it's a 2 or a 3 that comes up. Well, in this case, again, there's still 6 outcomes. But in this case, there's actually 2 numbers which satisfy a condition. It could be a 2 or it could be a 3. So it's 2 over 6, which is actually a third. Now what happens if we have, say, the condition, say, p equals probability it's 7? Well, in that case, that's clearly 0, right? There's no number on here that, 7 can never happen. That's literally impossible. There's 6, kind of, on no face of the dice, does kind of 7 show. So that's 0 divided by 6. What happens if we were to say, for example, if it was 2 and 3 shows up at the same time on kind of one row? Again, that's not possible. That's 0, right? So 0 over 6. So there's no outcome which satisfies that. So that's why we have a 0 here. And how we can see kind of zeros are kind of bottom limit, right? Probability. The probability something is impossible to happen. That's 0. That's what we're thinking about impossible. So as if we see a probability equaling 0, we might think this is completely impossible. That's what kind of I guess it relates to. And since we've kind of thought that this is that's the least a probability could be, what's the most probability could be? Well, let's say something like if it's probability of between the face shows 1, 2, 3, 4, 5, or 6, so any number 1 to 6. Well, in that case, there's 6 numbers which satisfy that. 6 outcomes would satisfy that, and there's 6 outcomes in total. So the probability is 1, i.e., kind of it's guaranteed to happen, or guaranteed to happen. So for example, in life, and sometimes you say something like, oh, it's 100% likely, right? It's gonna happen. It's how someone's like, how sure are you something's gonna happen? You say, I'm 100% sure. What you're really saying is then, for example, that the probability, a probability of 1 equals 100%. So when you're completely sure, you say, I'm 100% sure. That's kind of, I guess, if you think about that's where it comes from, and that's, I guess, the highest could be. That's that's something that's definitely going to happen. That's probability of 1, and something that's never going to happen. That's probability of 0. And you can realize that this is the range, right? Because what's more than definitely going to happen? There's no number higher than kind of you can't say I'm more sure than it's definitely happening, and you can't be kind of saying, oh, it's less than impossible. If it's impossible, it can't be kind of even more impossible than possible. So this is why probabilities kind of lie between 0 and 1. So that's a big thing that comes up. So probabilities lie between 0 and 1. You can't have, say, a probability of 1.5 of something happening. What does that mean? If something's guaranteed to happen, that's probability of 1. What does 1.5 mean? Or a probability of negative 0.5, for example. What does that mean? That doesn't really have a meaning when we think about where probability comes from and all that. That's in our relationship and kind of how we thought through what probability is. So now that we've introduced this idea and concept of probability as kind of thinking of it as some sort of way that we can mathematically talk about a random chance. This is a hard thing to talk about. You don't necessarily know what's going to happen, so you're trying to encapsulate and kind of talk about ways some random event is going to occur and think about the chance and the likelihood it will occur. That's what probability is. It's kind of you're basically putting a number on the likelihood of something happening. So a lot of the time you won't be too good at doing this. For example, like if you're thinking about the probability that Chelsea will beat Arsenal, or even kind of a bit more recently, Arsenal will beat Chelsea, I guess. I would have put the probability at something very low, say 0, but or close to 0, right? So maybe I would have said 0.00001%. The chance that Arsenal will beat Chelsea. But I was wrong, right? Arsenal did win. So in that sense, it's kind of like when humans estimate probabilities, they can be wrong. Your own biases feed into that. My kind of staunch belief in Chelsea fed into the belief that they'll win. I guess I was wrong. So that's, for example, a human bias that feeds in. And also, you can't kind of predict things with kind of complete accuracy. If I was to say, Chelsea will definitely beat Arsenal, and so the probability Arsenal will beat Chelsea is 0, you'd think that that's kind of a ludicrous statement to say, because you have to accept the fact that something could happen. Some player might turn up on the day and kind of really help Arsenal out. So that's kind of most people wouldn't ever kind of say that the probability of something in real life is zero. Or if you want to think about an example of something that's really likely to happen, for example, what's the likelihood that I'll produce p less than 2, for example, or you'll see p, or better yet, yeah, what's the probability, a p less than 2 exists? It's more than, it's quite, I'd say the probability of that, me making this next lesson is quite high. I'd put it very high. Maybe I'd put it at 0.999999 and so on. But I wouldn't put it at 1 because who knows what happens kind of, the next minute or, the next 10 minutes by the time I make p less than 2. Maybe my, computer dies and I can't make p less than 2 or whatever, some sort of freak accident happens and or p less than 2 is just not a nice sounding name. So I forget about it, I skip it or something. So in real life, we don't see things that, with a probability of 1 exactly or with a probability of 0 exactly. They can be close to it, very close to it, but most people would hesitate to say something is definitely going to happen with absolute certainty. I challenge you to actually think of something that you can think about that will happen with absolute certainty and kind of, ask a friend if they agree with you then, and more than likely they'll point out ways that, it might not happen. Even things like, say, I don't know, you seeing the moon or something in 4 weeks' time or something, or seeing the moon every month, who knows, maybe you might go by with a very, very cloudy month and you never see the moon, even though kind of, you didn't really expect the moon to be there, I guess. So, again, that in real world context, we don't kind of expect these extreme probabilities, but mathematically speaking, this is what our extreme probabilities are. Kind of with 0 being impossible and 1 being, definitely going to happen. And so anything along there you can kind of see as an intuitive thing, saying, the probability of 0.5, what does that mean? Does that mean it's likely or not? Well, that means, it's equally likely to happen or not to happen. So, example with a flipping a coin. Or if you think a probability of 6, you think, that's quite low, a 6 is quite low, that I might roll a 1, for example, So that's kind of why it's useful to, when you see the number of a probability, to kind of convert it in your head, to think about what it actually means in a real world context. But I'll stop rambling now about probabilities. Check out the next video, which I'll talk about more about probabilities and frequencies. But yeah, I'll see you guys there.